Hey, what's up YouTube? This video is on how to make a plasma speaker. So I've got my plasma speaker here and generating some plasma at the moment, and I'm going to show you how to make one yourself, so let's go. Okay, so I'll just move the plasma speaker over to here, just to prove that it works. If you just take a look here, then put those guys together. There's the plasma there, look, so you can see it. It's pretty powerful stuff actually. If you look at this, it doesn't take very long, but it heats things up pretty well. So it's pretty cool stuff. It's not yet playing music. We'll get to that in a minute. First step to making a plasma speaker is obviously to generate the plasma. So that's where we've got to at the moment. I'll just talk you through about what items you need. So firstly, you need a 555 timer. That's this guy hidden here. You need two capacitors, the same value. I'll put the values up in a minute. Two resistors, again of the same value. A few jumper wires, obviously. An IGBT or MOSFET with a heatsink. Flyback diode. I've got one just hidden in there. You can see it. So a special type of diode used in this case as a flyback, and I can put that up there. The IR2110, which is a high or low side driver. A few caps around here, another diode. I've got a 5-volt regulator here, which is providing the logic for this IR2110. And then lastly, we've got this inductor or transformer. So this is a coupled inductor. You can wind your own. It's very simple to do. So if you just find any old type of relay or any old transformer, you can take the windings off of that, you can take the copper off, and you just basically wind this around some ferrite. So if you've got an old transformer lying around, so I've got one here which I may use, you can just take this apart, take the windings off and wind your own on there. Really not difficult. I basically did about 100 secondary turns, so this has got about 100 secondary turns on there to about 4 or 5 primary turns there. Basically what this does is you're switching so this is my input supply. It's coming from a 12-volt source. Basically what you're doing is you're switching that across the primary coil in sort of a fashion like this. So if I show you basically what we're doing is we've got a primary winding on the transformer like this, and then we've got more turns on the secondary like that. And basically what we're doing here is we're putting some voltage, 12 volts in my case, across here, and then we've got our switch, which is this guy here, and this goes to ground. And basically all we're doing is we're closing this, and that's putting a large amount of current flowing through here. Because this is a coil, it starts generating a magnetic field as an inductor. That's what it does. The ferrite around here sort of couples that magnetic field into the second transformer, and we get a voltage increase on this side. Now the equation that you need to concern yourself with an inductor is this one, which is the voltage across your inductor is equal to di dt, which is basically just your change in current in your change over your change in time, multiplied by your inductance. So what this really translates into is if we're, and a transformer is basically an inductor for all intents and purposes, if we're putting a voltage on like this, so we whack our coil up to 12 volts and then suddenly turn it off, this is basically, if we zoom in here, this period here is your d of t, and your change of current is quite drastic because at this point we're probably, I don't know, drawing maybe about 3 amps, maybe more, because essentially it's practically a short. You've just got I don't know, a coil with about 5 turns of wire on it, and you're just putting that across a supply. So you could have as much as 3 amps up to there. So we've gone from 3 amps to 0 amps in a very short amount of time. And if we plug that into the equation that we saw, we've basically got 3 amps here, and D of T is going to be very small. So let's just say, for all intents and purposes, I don't know, well, this is probably even shorter than that. That turn-off time could be as little as 600 nanoseconds. So you've got 3 divided by a very small number, multiplied by its inductance, which gives you a very large voltage. So that means that the voltage on our primary coil here, this voltage, is very big. And what that does is that generates a very large magnetic field, which is then coupled into our secondary inductor, or secondary part of the transformer, and this is where the transformer action comes in, and we're stepping the voltage up from 1 to 100 or something like that. So we've already got a very large voltage which we're stepping up by 100 times, and that's how we generate the plasma. And the plasma is pretty interesting, because basically what the plasma does, the reason that we're generating plasma in the first place, is we've got essentially 2 points like this. So this is my wire. This is this bit here, and what we're doing is we're putting loads of charge, or very high voltage, across these 2 points. So this one's very negative, this one's very positive. It gets to the point where the atoms in the air, their electrons start getting ripped out, and you ionize the air, and those free-flowing electrons become your charge carriers, which is your current, and they short across here, and that's how you get the plasma. So you're actually ripping the electrons out of the air here to generate your charge. And that's basically how it works. Now, so mine at the moment isn't playing any music, and the reason it's not playing any music is I haven't plugged anything in yet. But the way that we're going to do that is, in order for me to maintain this plasma, I need to run this at quite a high frequency. So I'm running mine at about 20 kilohertz. Reason for that is that it's above the audible range. So humans, we can hear anywhere between 20 to 20 kilohertz. So if I choose let's say a plasma frequency of above 20k, then I can modulate over the top of this audio. So if you just imagine that this signal I have here, that's my 20 kilohertz signal. So this here is 20, not there. From that point to that point is 20 kilohertz. What I can do over the top of that, if I want to play, I don't know, the note A, so whatever an A is in hertz, something like 441 hertz, I'm not too sure on that, but let's say for all intents and purposes it's 441 hertz, then what I just need to do is over the top of this, I need to play this at 441 hertz, and it won't be to scale, but it will look something like this. So I'm doing 20 kilohertz for this moment, and then I turn it off, and then 20 kilohertz again, turn it off, 20 kilohertz again, turn it off. And now what I'm saying is these points here, that happens 441 times per second. And that's how this is the principle of making music, is that basically you're generating a spark here, turning it off, generating a spark here, turning it off. And this does exactly the same thing that a loudspeaker would do. So if you had a loudspeaker like this, and it was generating sound, basically what it's doing is it has a cone here that's forcing the air backwards and forwards, and it gives you a longitudinal wave, which is what sound waves are, they're longitudinal. And what we're doing is we've got our 2 bits of wire, and we're generating our plasma between it, but we're turning that plasma on and off at a certain frequency, and that's the frequency that heats the air up and cools the air down, heats the air up, cools the air down, and that's what produces the sound waves again. So we can get music here, and we can get music here. And that's the principle behind it. So what I've got at the moment is I've just got the 20 kilohertz frequency like this. Oh, I have to put those a bit closer together. There we go. So that's what I've got at the moment. That's not playing any music at all. And that's the basis of the plasma speaker. So the next steps for me are, I've got my 20 kilohertz frequency being generated here. It's going into the IR2110. If you don't know how to use an IR2110, my previous video explains all about that. And I'll put the circuit up now for you guys to see. But really there's nothing that much basic to it, really that much difficulty there for you. One thing I will say is that it's very inefficient, so this heats up a lot. And the reason for that is quite simple, is that basically we're driving our MOSFET like this. So it's going 12 volts to 0 volts like that, in a step like this. The DC average of this is about 6 volts. So that means whatever current we've got flowing through, the current will look something like this, I think, because it's an inductor, so it's going to be sort of ramping up, ramping down. This will also have some DC value, let's say it's 1.5 amps or whatever it is. Your power dissipated, it will be 6 times 1.5. It gives you 9 watts as a rough number. That's being dissipated in your MOSFET, multiplied by, I think you might have to multiply this by your frequency or something like this, but basically the point is that you've got some DC content here. If we were to drive this coil more like this, so if this is now 6 volts and this is minus 6 volts, and we were to drive the coil like this, then the average is 0 and you get a lot less heat dissipated. So this is my next step that I'll do before I start making it play music, is to reduce the heat, because at the moment I can't run this for very long at all because it'll overheat. So that's the next step. But yeah, so thank you for watching. That's pretty much where I'm at the moment. If you have any questions on how to make a plasma speaker, please put them in the comments below. It's very simple. Just be careful, don't touch anything, because it will be very painful if you do. And yeah, please subscribe, and you'll shortly be seeing a video of this playing music.